Tell me more.
It's that everything you think, and the only reason you can use is natural things. It can't be anything supernatural.
Right. Very good. Yeah. And we're going to talk about that some more today. So, good.
I was just thinking, when the total amount of data in the world is everything we know. That whole section.
Yeah.
That's crazy.
It's remarkable to think about. And some of that data are cat videos too. But, Lexi.
A lot of things, but one of them is that God used the same template for all of his creation, and like think about why he did that, and also showing like he could have made different templates, but how creative was he with the same template?
Yeah. Good. Yeah.
I thought the stuff about the ATP innocent days was pretty cool.
Yep, it is cool. Very cool. And hopefully that leaves you at least with an impression of just how remarkable the designs are that we see in nature, right? Just how awe-inspiring, even, in the realm that's not visible to our naked eyes, where you have to construct what's going on indirectly through different techniques, you still see this incredible creation. Yes?
It was most of the talk, but how so much of biochemical machinery predates human machinery and how they resemble each other, but how much earlier the biochemical stuff came
Yep.
about. We modeled it without even trying to model it.
Yeah. Great point. Yes?
I thought the DNA computing stuff was wild. I've never heard of that.
Yeah.
That just kind of blew my mind. Just the way that humans are just continuing to
Yeah.
further science and everything. I'm just that's
Yeah.
absolutely insane to me.
Yep. It is insane.
It sounded insane when I tried to explain it to someone else last night. I was like, this is really hard.
All right. Well, that's good. That's good. Well, what we're going to do today, this morning, is we're going to take a look at 3 areas of science faith ideas that tend to raise questions and concerns for Christians. And what we're going to be talking about are some ways that we can think about these potential challenges to our faith. One is evolution. One has to do with the age of the earth. But in that particular discussion, we're going to approach it in a very different kind of a way than you probably are used to if you're familiar with any kinds of those conversations. And then the last area we're going to talk about is the idea that there's animal death in the creation, and how do we make sense of that. So that's kind of the roadmap for this morning. Again, please feel free at any point to ask questions, to raise points of concern. All right. Well, let's get started. So what we're going to be doing, first of all, is, jumped the gun here, is asking the question, how should we as Christians think about evolution? And I'm just curious, when I bring up the term evolution, what is the first thing that goes through your mind? What's the first thing that comes to your mind? Yes?
Something changing to adapt to its environment over time.
Okay. Yeah, so you think about the definition of evolution. Cooper.
Macroevolution, things evolving outside of their kind.
Yeah.
How animals eventually turn into humans.
Yeah. Does yes.
I just think it's false.
Yeah. When it comes to evolution, there really are almost 2 responses that Christians have that really lie at 2 ends of the spectrum. One is, as you said, just to approach it with a lot of suspicion, questioning if it's even valid. And then the other approach is just to accept it and then to try to make a case that maybe God could create through evolutionary means or evolutionary mechanisms. And what I'm going to present here is kind of a middle ground where it encourages us to think carefully and critically about evolution, but to not necessarily adopt a posture of immediately rejecting ideas in evolution, but also adopting a posture where we don't necessarily immediately accept those ideas as well, and that we are informed by our faith appropriately in terms of how we engage ideas involving evolution. And these are going to be hopefully the 4 takeaway points that you'll have. One is that definitions are very important, and I noticed a number of you provided definitions about evolution. We want to recognize the role that philosophy plays in the evolutionary model, in establishing the credibility of the evolutionary model. So we're going to bring up this idea of methodological naturalism. We're going to point out that there are some scientific challenges that do exist to evolution, and that this is going to be the most important point, that evidence for evolution can be readily accommodated in a creation model framework where you see God as creating in a direct, personal way, right? So the first question on the table, or the first point, is what is evolution? And again, a number of you brought up different definitions. But before we actually talk about what is evolution, we need to talk a little bit about what the theory of evolution entails. And we're going to be talking about Darwin's ideas, but it's also important to recognize that evolutionary biology has moved beyond Darwin. There are very few evolutionary biologists today that would actually call themselves Darwinists. They would acknowledge they're evolutionary biologists, but they would argue for different versions or variations of evolution. But the idea that Darwin presented with his theory of evolution is still, in a sense, in the backdrop of all the ideas that people have about biological evolution. And the idea here is that you have a population of some kind of species, and in that population there's variation in terms of the different traits that those species possess, and that those variations are heritable. They can be passed on to the next generation, and that those particular traits that improve fitness, which includes survivability and reproductive success, will increase in the next generation at the expense of traits that don't contribute to the same degree to fitness, and that over time, species can adapt to their environments and undergo changes, and over a not long enough period of time, if there is isolation of that population into fragments, into a fragmented population, that different species can actually arise from an existing species. And so when Darwin presented his theory of evolution, he was working on what was a problem called, in that day, the mystery of mysteries, which is how do you explain the origin of species? So Darwin's theory of evolution does a wonderful job of explaining how new species originate. And sometimes this is called his special theory. But then what Darwin did is he argued that this same mechanism could be extended over long periods of time and account for large-scale biological change. That this could not only explain the origin of species, but the origin of major biological groups. That it could explain the diversity of life that we see today, the diversity of life that we see throughout Earth's history, that it could explain what are called the biogeographical patterns, the distribution of organisms on the planet, where they live. And Darwin even said that his theory could explain the exquisite adaptation organisms display for their environment, and in fact the appearance of design. And when we look at biological systems, this was the idea of William Paley. These systems appear to be designed, right? And Darwin argued that even that appearance of design could be explained by evolutionary mechanisms. And so what Darwin did is he took biology in a completely different direction with his theory. That prior to Darwin, we talked about some of the ideas of Sir Richard Owen, right? Biology was steeped in design ideas, that the designs in biology were the work of a creator. People may have debated different ways to make sense of those designs in terms of cataloging them and organizing them, but nevertheless, that there was real design, real purpose in biology. And Darwin comes along and he replaces the mind of a creator with the mechanism of evolution. And now suddenly, everything in biology is explained mechanistically. There is no need for a creator whatsoever. And there is no ultimate meaning or purpose to anything in evolution. And so Darwin stripped design, or teleology, you might say, from evolution and from biology. And this is sometimes called the Darwinian Revolution. And today, most biologists simply can't even conceive of how you would think about biology apart from evolution. It's considered to be the organizing principle in the same way that bonding theory is the organizing principle in chemistry, or that general relativity and quantum mechanics are organizing principles in physics. The argument would be evolution is the organizing principle in biology. A famous geneticist wrote in the 1970s that nothing in biology makes sense except in light of evolution. Richard Dawkins once wrote, "It's absolutely safe to say that if you meet somebody who claims not to believe in evolution, that person is ignorant, stupid, or insane, or wicked, but I'd rather not consider that." And so what's behind these two statements, one I think more civilized, one much more harsh and hostile, is this idea that, again, evolution is this well-established fact. It's the organizing principle in biology. Nothing makes sense in biology unless you think about life evolving. And yet, we're going to talk about the fact that there are scientific limitations to the theory of evolution, and there's another way to think about biology following in the footsteps of people like Richard Owen. Now, this leads to the question, so why is evolution troubling to people that hold to the Christian faith, right? Why is it troubling? And I think based on statements that when you understand the nature of evolutionary theory, that it strips design, it strips meaning and purpose out of biology, that when you see statements like Richard Dawkins makes, that Christians are concerned because the belief is that God is the creator of life. He sustains life. He directs life's history. And I've met a number of people who are steeped in the evolutionary paradigm who say, if evolution can explain everything in biology, what role is there for a creator to play? In fact, I was sympathetic to that idea myself. And then also, we have this view as Christians that human beings are made in God's image, that we are the crown of creation. And in evolutionary theory, this idea of an Adam and an Eve from which all humanity originates, the idea that human beings are exceptional, that we stand apart from all other creatures, is simply not an idea that is compatible with evolution. And so this cuts at the very core of who we think we are as human beings from a Christian worldview perspective, and ultimately undermines the gospel itself. And so we're going to talk more about this tomorrow morning when we talk about how can we preserve the idea of the image of God in an age of Darwin. Yes, Nick?
So I feel like I don't know, I've never really heard an evolutionist or someone who claims to believe that, right? Atheist who believes in evolution, explain away the Y chromosome that you brought up in
Yeah.
the previous class, or the fact that all humans have a similar tracing back DNA. Does evolution have a way of explaining that? Or
Yes. Yes. What they would argue is that that yes, indeed, there was a mitochondrial Eve and a Y chromosome Adam, but that Adam and Eve were, or that mitochondrial Eve, Y chromosomal Adam, were two individuals that were part of a larger population, and they just happened to be the lucky individuals whose genetic fingerprint persists till this day, where all the other people that were alive at that time, their lineages essentially died off, right? So the argument is that they weren't even the first human beings, that there were humans that were prior to them, humans that existed alongside them, so that they were just simply the two lucky individuals whose lineages survived. And what's going on there is that, and this goes to this point, is that evolution is a population level phenomena. And what I mean by that is many people think it's the individuals that in a population that are evolving. They're not. It's the whole population that's evolving. And so by definition, you have to have a population if you think about the origin of humanity in evolutionary terms. So there is a way around that from an evolutionary perspective, if that makes any sense, right? But it's that is as much a commitment to viewing human origins in an evolutionary sense as it is actually what the data demands, right? So I don't know if that helps. Yeah. This is what Dawkins said, that the theory of evolution makes it possible to be an intellectually satisfied atheist. And again, this goes to this idea that if, again, evolution can explain everything in biology, what role is there for a creator? We'll revisit these next couple of slides tomorrow. But yeah, this is an evolutionary tree showing every major group of organism that we know of. This is a pretty remarkable diagram. And on this tree, human beings are right here. It's a little tiny little branch. And what this emphasizes is that if you start thinking about, again, life in evolutionary terms, it means that human beings are just part of this tangled network of evolutionary branches, that we're no different than any other creature that exists. There's nothing special about us. We have no inherent value, any more so than any other organism that has ever existed in Earth's history. We're just part, again, of this evolutionary tree of life. And that we are a minor, late-appearing branch that is relatively insignificant. And that many people see the evolutionary process as being historically contingent, meaning it's based on a sequence of chance events, and that if you alter any one of those events ever slightly, you're going to get a very different evolutionary trajectory. Or another way of saying it is that if you rewind the tape of life and let it play again, the outcome is going to be different, which means human beings were just a lucky happenstance of the evolutionary process. We weren't intended. There's nothing in the process that is anticipating our arrival. We are just a lucky accident. And Stephen Jay Gould says this means that we must face the implications squarely that the origin of Homo sapiens is a tiny twig on an improbable branch of a contingent limb on a fortunate tree lies well below the boundary. In Darwin's scheme, we are a detail, not a purpose or an embodiment of the whole, with the details, whether good or bad, left to the working out of what we may call chance, right? So,
I think it's ironic. His book is called Wonderful Life.
yeah. Well, but it's, to your point, many biologists, even though they have this perspective on life, still celebrate the world of nature. They see it as wonderful. In fact, people like Gould would say, because human beings are just this lucky happenstance that we weren't really predicted, that means that in some ways we are special and that we should treasure and value humanity because we very well could not have been here. And so they look at the biological realm and celebrate it because they see what's in front of us as just being simply the luck of the draw. And so you appreciate things because of the fact that it's just this lucky occurrence. So it's an interesting way of thinking about things. But the larger point is that there are good reasons why Christians are skeptical about evolution, right? Because it attacks the very core of this idea that there is a creator that orchestrated the history of life, that has an intention and a purpose for everything that he does, and that it undermines ultimately our place in the cosmos as human beings and the view of humanity being exceptional and being unique and special. Okay, so the next question, isn't evolution a religion? Isn't evolution based on faith? I hear a lot of people say that evolution is just as much based on faith as Christianity is, right? And I would disagree with this. I don't think evolution is based on faith. It's not like there's no evidence for biological evolution. But it is based on philosophy, and this is going back to a point we made earlier, and that needs to be revisited, and this is this idea of methodological naturalism. Is that there's a view called philosophical naturalism, which is this belief that God does not exist, right? That's atheism, that's materialism. God does not exist. That's called philosophical naturalism. A companion idea is called methodological naturalism, and this is the philosophical framework in which science operates. As we talked about, again, it's worth revisiting this because this is a very important point. And that is that methodological naturalism is this idea that when you engage in a scientific investigation of the world, that you can only appeal to materialistic processes, to mechanistic processes, that any other possible explanation, particularly explanations involving design, right, or the work of an agent to account for features in biology, is taken off the table ahead of time. And so a lot of the evidence that is cited in favor of evolution is evidence that could readily be accommodated in a design framework. It's just that framework isn't even given a place at the table. Do you understand that? And so by definition, evolution must be true because that's the only possible explanation you have. And so a lot of times you'll see people say, evolution is a fact, the theory is how did it occur? And so people will debate how it occurred, but the fact that it did occur is taken as a given, and it's for philosophical reasons as much as it is scientific reasons. And so just to get a sense for how powerful this idea is, this is an interesting statement made by Richard Lewontin, who is an evolutionary biologist. And Lewontin says this: "We take the side of science in spite of the patent absurdity of some of its constructs, in spite of its failure to fulfill many of its extravagant promises of health and life, in spite of the tolerance of the scientific community for unsubstantiated just-so stories, because we have a prior commitment, a commitment to materialism. It's not that the methods and institutions of science somehow compel us to accept the material explanation of the phenomenal world, but on the contrary, that we are forced by our a priori adherence to material causes to create an apparatus of investigation and a set of concepts that produce material explanations, no matter how counterintuitive, no matter how mystifying to the uninitiated. Moreover, that materialism is an absolute. We cannot allow a divine foot in the door." Right? And so the point here is that again, even though there may be scientific challenges to the theory of evolution, those challenges don't count against the theory, right? Because it's the only option that you have. Some type of evolution must explain the world that we live in. Okay? All right, so if evolution is the prevailing scientific view of origins, don't we have to accept it? And I think this is where it becomes very important to know exactly what we mean when we talk about evolution. Because evolution simply means change over time, right? Change in biological systems over time. That's what evolution refers to in a biological context. And when we look at biology, there are different types of change that can take place over time. So, for example, there are some forms of biological change that don't fundamentally challenge the idea that there is a creator. That these are mechanisms that essentially take existing designs and fine-tune those designs. They vary those designs, but those core designs are still in place. And this would include microevolution, speciation, and microbial evolution. Sometimes you might call, we'll talk about each of those forms in a minute. Now, other forms of evolution actually do challenge the idea of God as creator. This would be macroevolution, where evolution is now being granted creative power and potential. Right? That evolution has the ability to convert one major group into another. Or chemical evolution, the idea that molecules can self-organize to produce the very first cells. These are aspects of evolution that directly challenge the idea that there is a creator that's necessary. Because again, what's being suggested in these forms of evolution is that mechanism can replace the mind of a creator. So let's just look at some of the examples of these different types of evolution, and maybe some of these examples are familiar to you. One of them would be microevolution. One of those examples, would be the peppered moths. All right, these are shown here in this particular diagram. Are you familiar with the peppered moths from your biology classes? Right? The idea here is that this is the normal variety of peppered moths, and that when there was an increase in pollution in the United Kingdom, that the peppered moths became almost entirely black. The population was almost always black. Well, it turns out that this variety actually exists naturally within the population, but because this provided camouflage to avoid the moths from being consumed by predators, that it increased their survivability, and so the population increased in terms of the number of black individuals. This is a microevolutionary change, an adaptation to the environment, and when the pollution was cleaned up, the population of peppered moths reverted back to this particular peppered variety. So nothing is happening other than the wing color and the coloration of the moths are being altered. Speciation would be one species giving rise to another species. Perhaps you've heard of the Galapagos finches, right? Where you have a number of different finch species on the Galapagos Islands that presumably originated as a finch species, made its way there, and then began to populate the different features of the island, different regions, and underwent basically changes in the size and the shape of the beak and the size of the body. Those were basically the changes. These are still finches. They just are, again, different varieties of finches that we would classify as distinct species. Here's another example where you might call this microevolution. Maybe you've seen this example in textbooks about horse evolution, where you go from horses that were roughly the size of dogs to horses that are of the size that we're familiar with today. And you see these different transitional forms in the fossil record. And people will point to this and say, look, this is clearly evidence for evolution. And indeed it is. But this is microevolution. All that's happening is that the size of the horse is getting larger, the structure of the foot is undergone an alteration, and the dentition or the teeth have changed in response to different types of environments. But this transition is happening over 60 million years. So these are relatively minor, small changes that again are easily understood as examples of microevolution and speciation. In fact, you could even argue that microevolution and speciation are evidence for design. Now, why would I say that? Why would I say that? And this goes back to the idea of God's providence, that God has created a world where he's instituted certain processes, and those processes that he's instituted allow the creation to be sustained. And so I see microevolution and speciation as being an example of God's providential care, where he has given organisms the ability to respond to changes in the environment as a way to, again, ensure their survivability. And so you easily can see this as being, again, part of the design of creation that reflects God's providence. Another example of evolution that I think is well established is microbial evolution. Bacteria evolving the ability to develop resistance to antibiotics, as an example, right? We're familiar with, hopefully, with superbugs. These are antibiotic-resistant bacteria, and it's the capacity of these bacteria to acquire resistance to antibiotics is complicated, but it is an example of an evolutionary process. Or we're familiar with, the COVID-19 virus, right? Because we've been through a pandemic. And one explanation is that it's through what's called zoonotic transfer, where a virus that naturally infects an animal undergoes a mutation that then allows it to hop hosts and infect human beings. This is a common occurrence. And so this is an example of again, of microbial evolution. So the point here is that there are some facets of the evolutionary paradigm that are well established, that are not controversial, that for Christians really raise no fundamental question about God's role as creator. Now, there are other types of evolution that do. One is called chemical evolution. It's also called the origin of life, or abiogenesis. And here the idea is that, again, molecules can self-organize into the very first cells. And this is, again, replacing the creator with the mechanisms of chemical evolution. Another example would be, macroevolution would involve things like dinosaurs evolving into birds, or a wolf-like creature evolving into whales, or apes evolving into humans. Here, again, you're ascribing creative power to the evolutionary paradigm. So these are places where it's legitimate to be skeptical, to be concerned, to have doubts, to raise questions as a Christian about these kinds of claims. But there's other aspects of the evolutionary paradigm that we should be very comfortable with, that we don't need to be concerned about. Now, definitions are important, all right? And sometimes you see played what I'll call the shell game of evolution, where people will talk about evolution being a fact and then use evidence for evolution of one type for evidence for evolution of another type. And so people might say, well, that we see, for example, that horses have undergone an evolution over 60 million years. Therefore, it's completely reasonable to think that a wolf-like creature could evolve into a whale, right? Those are two very different types of evolution that's being described. You can't use evidence for evolution that involves the origin of modern horses as evidence that a wolf-like creature that lives on the land could evolve to be an aquatic mammal, right? You can't use evidence for one as evidence for the other. Does that make sense? And so you see the shell game played quite a lot. So you always want to be sure you're paying attention to what is being described when it comes to evolution. And let me give you a concrete example of this. This discussion came up yesterday after class. I think, Lexi, you and I were talking about it. I don't know if you realize this, but human beings are evolving, that we are evolving over time. And one evidence that we are evolving is the ability for humans to digest milk sugar as adults. Now, I don't know, maybe this is TMI, but I'm lactose intolerant, and so I just have to be very careful about what I consume. Now, as it turns out, some people can tolerate dairy products throughout their entire lives. Well, people that can actually tolerate dairy products are mutants, right? Whereas I'm genetically pristine as being someone that's lactose intolerant. No, the idea here is that there's an enzyme called lactase that a lot of animals will produce, including human beings. And that enzyme allows you to digest lactose, which is the sugar in milk. And that enzyme is expressed for the first couple of years of life, but by the time that you wean from your mother, that enzyme is no longer being produced. Meaning that there's no reason for your body to produce that enzyme because you're no longer consuming milk, right? That's the normal state. But it turns out that in humans, particularly at the time where we began to establish human civilization and began to domesticate plants and animals, around the world, different people groups actually independently evolved the ability to digest milk sugar into adulthood. And what's going on is that there's a mutation in the regulatory region of the lactase gene that alters it such that the lactase enzyme is continually expressed into adulthood, which means that you can then continue to digest milk sugar, right? And that's called lactase persistence. So this is something that's well established. That is, again, evidence that human beings have evolved. But what kind of evolution is this? Anybody? Yeah, microevolution. But I've seen people say, well, human beings are evolving. The exact example of lactose persistence emerging in human populations is evidence that human beings are evolving. Therefore, human beings must have evolved from an ape-like creature. You see how the shell game is being played there? Right? So just be aware of definitions. Yes, indeed, humans are evolving, but that doesn't mean that human evolution is valid. You have to demonstrate that in a completely different way.
How do we know that the first people put in processed milk longer?
You can actually reconstruct genomes, and you would know that that would be the case. You can identify when mutations took place that would alter the regulatory behavior of lactase. You can work your way backward and figure it out. It's very similar to knowing what an original manuscript said. So, for example, you might have a whole bunch of manuscripts available for some particular ancient text. And you compare those manuscripts, you note that there are these what appear to be copying errors where the scribes that would produce the manuscripts introduced mistakes. And then the next scribe that was copying that manuscript would copy the mistake, right? But by studying the manuscripts and knowing when they were dated, you can actually work your way backward, comparing the different mistakes and reconstruct what the original manuscript would have said. Yeah, and you can identify where those copying errors took place.
That much information to do it with?
Mm-hmm. You could do it from taking genetic samples of people in this room, probably. Yep. Okay, now, are there scientific challenges to evolution? And the answer is yes. right, is that when it comes to scientific challenges to evolution, the places where we see the challenges involve chemical evolution and macroevolution. And we talked a little bit yesterday about the idea that nobody knows how the origin of life could have occurred, right? We talked about that problem. But there's other key transitions in life's history where evolutionary theory breaks down. The origin of what are called eukaryotic cells, the origin of body plans, the origin of human uniqueness, and the list could go on and on. That is, that there are places in life's history where there are key transitions, where life goes from one regime of complexity to another, and during the course of those transitions, or those transitions can't be accounted for by current evolutionary theory. Current evolutionary theory struggles and faces significant scientific challenges there. And so these are, again, the key transitions in life's history, and evolutionary theory can't explain them. So there are scientific challenges. I'm not going to get into the details of this, just so that you are aware. There's also places where there are key predictions that are made by the evolutionary paradigm, and that those predictions turn out to be invalid. And I'm not going to get into the details of this other than, again, just simply pointing out that there are legitimate scientific shortcomings to the theory of evolution. And many evolutionary biologists will readily acknowledge that or readily admit that. Okay. What is the scientific evidence for evolution? And now I'm talking about macroevolution, right? What is the scientific evidence for macroevolution? And typically what people will say is that the evidence for macroevolution, oops, there was a mistake there in the slide, is the fossil record in homology. These are in other words, they would argue that, look, when you look at the fossil record, you see life going from simple to complex. You see that there are different organisms at different times in Earth's history, and this is very clearly evidence that evolution has transpired, right? Or they'll say that when we look at organisms, we see shared homologies, shared biological features, that this is evidence for common descent. And we talked a little bit about that yesterday. So when it comes to the fossil record, again, people will argue that this is evidence for evolution. But when we look at the Genesis 1 creation account, there are different days of creation. And on the first 4 days of creation, God is transforming the earth so that the earth would be a place that would be suitable to introduce animal and plant life. And then what we see on days 4, 5, and 6, the introduction of plants, the introduction of different types of animals, and ultimately the creation of human beings. So in other words, what we see through the Genesis 1 account is that God is introducing different life forms at different times in Earth's history, right? And so there is a progression of what God is doing as he creates. And so there's no reason to think that just because there's a history of life on Earth, that this is incompatible with Genesis 1. It's not. And the fact of the matter is, when we look at features of the fossil record, these features don't fit what you would expect in an evolutionary model. So David Ropp, a paleontologist, said, instead of finding the gradual unfolding of life, what geologists of Darwin's time and geologists of the present day actually find is that species appear in the sequence very suddenly, show little or no change during their existence, and then they abruptly go out of the record. So it looks like that instead of seeing a gradual evolutionary change in organisms, we typically see, again, stasis or no evolutionary change. We also see very precious few true transitional forms. All paleontologists know that the fossil record contains precious little in the way of intermediate forms. Transitions between major groups are characteristically abrupt. So the point here is that the fossil record doesn't necessarily, again, show the features that we would expect if it was indeed an evolutionary history of life. It does show a history of life, but you could argue that that history of life is easily explained from a creation model perspective. Again, noting in Genesis 1 the progression of life. But on top of that, when you start talking about there being abrupt appearances, that to me is a signature for God's work as creator. What would it look like if God is intervening to bring about his creative purposes? Wouldn't you expect to see abrupt appearances? Now, what about homologies? We talked about this yesterday, right? But this is, again, I think worth repeating in this context, because the concept of homologies basically is intertwined with the evolutionary paradigm, where people see shared biological features among organisms that naturally group together as being evidence for a shared evolutionary history, evidence for common descent. And this is an example of homologies, actually, that we would all be familiar with, right? I don't know if you ever thought about this, but if you open up a silverware drawer, notice that there are these shared features that the forks have, that these two forks have similar handles, that here are 3 knives, similar handles, spoons, similar handles, right? That this is an example of homologies, right? And yet homologies are things that we naturally produce when we create objects, right? And so you could easily see homologies from a design perspective. But the idea, again, is that homologies predate Darwin's theory. They're part of a theoretical framework developed by Richard Owen prior to Darwin, in which he advanced this idea of the vertebrate archetype, where he argued that this is the ideal or original or fundamental pattern on which a natural group of animals or system of organs has been constructed into modifications of which the various forms of animals or organs may be referred. And again, this is a really important concept, because it means that you could see common design as being the explanation for homologies, not common descent. And and so when we look at, again, things like the genetic similarity between humans and chimps, we could easily see this as reflecting common design, not common descent. All right? So, hopefully this gives you just a little bit of sense for how to think about evolution. And really, the takeaway points are this, that definitions are really very important. Make sure you identify what type of evolution is being described, and make sure that the shell game of evolution isn't being played, right? And that we don't have to reject evolution in its entirety, but rather we want to think critically about it, and that we should be suspicious about some aspects of evolution, but other aspects are something that we can readily appropriate, that there are scientific challenges that do exist. We didn't go into a lot of those details, but that ultimately, and this is another very important point, that the evidence that many people cite as being unequivocal evidence for evolution could be readily understood as being evidence or being accommodated within a creation model perspective. Okay, any questions, comments, thoughts? Nick?
Would you say that the Neanderthal theory of humanity's more older ancestors, I guess, would fit into the micro or macro version of evolution?
I would consider that to be macroevolution. And we'll talk about that tomorrow. But yeah, I think creatures like Neanderthals were real creatures that existed, but that But I don't see them as being evolutionary intermediates. I see them as creatures that God created that existed and then disappeared. That I see them as having some intelligence and emotional capacity, but I see see them as fundamentally distinct from humans. And there's emerging data that indicates that the brain structure of humans and Neanderthals was fundamentally different, right? So I would see these creatures as lacking the image of God and that only humans bear God's image. So when you look at Genesis 2, it talks about Adam being made from the dust of the earth and then God breathing the breath of life into him. Genesis 2:19 talks about the animals being made from the dust of the earth, but they don't receive the divine breath. And so what that tells me is that humans and animals would have similar biological features, but that humans stand apart, and what causes us to stand apart isn't our biology, it's actually the fact that we are image bearers. And so I would argue that when we look at humans and Neanderthals, the differences that we see in their behavioral capacity and their cognitive abilities reflects the fact that humans bear God's image and these other creatures would not have. Doesn't mean that they didn't have some measure of intelligence or emotional capacity. Right? But the more that we are studying animals, the more that we're understanding or recognizing some fairly sophisticated behavior in animals, some measure of intelligence in animals. But again, I don't think anybody would see a dog and a human, for example, or a chimp and a human in the same category, right? And so I think of Neanderthals like that they were animals. Does that help? There was yes.
How is, like, when people look at macroevolution, how is it not just summed up to just a bunch of microevolutions? Just like micro, 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 and they just kind of smush it and be like, oh, it came from this, now it's this.
Yeah, well, that's the argument, is that that microevolution, if you extrapolate it over long enough periods of time, it can account for large-scale biological changes. There's a couple of problems with that. One is that those mechanisms can't explain, for example, the origin of life. They can't explain the origin of eukaryotic cells, right, or the origin of body plans. So these mechanisms, there are biologists that are now arguing that evolutionary theory is incomplete. That if we're going to truly explain the history of life on Earth, we have to expand evolutionary theory beyond its current parameters. And this is called a call for the extended evolutionary synthesis. And they're saying that there's other insights from other areas of biology that need to be incorporated. But there's a growing recognition that again, how do you explain the origin of body plans? How do you explain the origin of biological novelty? They're just not models that explain that, right? How do you explain how you transition from bacterial cells to eukaryotic cells? Those are things where that theory just doesn't work. So giving more time isn't going to work. And people that are suggesting answers to these questions are proposing things that are non-Darwinian ideas that aren't relying on those mechanisms. So, so that doesn't work. Also, when you look at a lot of transitions in life's history, they happen abruptly. So there are these events that are called radiation events in the fossil record, where when innovation happens, it just happens explosively. So there's something called the mammalian radiation, where all of a sudden you just see an explosion of mammalian groups that just happen in a geological instant, right? The Cambrian explosion is another example, where clearly what's happening there isn't gradual accrual over periods of time. Yeah, so. Was there somebody else with a question? Okay. All right, well, why don't we take a break? It is, why don't we plan on starting at 5 after 10? Okay?